So today we're going to talk about how you can use AI Architect to build trusted agents in just a couple of hours. So let's go ahead and get started. So first, I'd like to introduce our CEO, Barbara Tallent. Barbara has a remarkable track record of scaling and exiting companies to giants like Siebel Systems and driving the growth of the educational platform LiveBinders to over 1 million customers. And joining Barbara is our CTO, Colin Constable, also a co-founder. Colin has led enterprise architecture at Jupiter, easy for me to say, Juniper Networks and Credit Suisse, and famously built out Deutsche Bank's custom innovation lab here in Palo Alto. So with that, I'm going to disappear and hand it over to Barbara and Colin. Thanks.
Great. Thank you. Colin, do you want to go ahead and do a screen share?
I will do that. Let's see how clever I am today. Did that work for you? I think so.
Yeah, that's great. So the first thing that we want to talk about, just the whole AI agent space is going crazy. Everybody is adopting these things. But let's define what an AI agent is, just so that we're all starting from the same level. So an AI agent is an autonomous system powered by an LLM that doesn't just answer questions, but actively reasons through tasks and executes them. And it does that by using external tools. So it's autonomous planning. So it breaks down complex goals into multiple steps and workflows. It has tool integration. So it takes action via APIs or databases or protocols like MCP. And it has stateful memory, so it learns from past interactions and adapts to new information. That last part, people are a little, it's not always doing exactly what it's supposed to do there, but we can guarantee that things will get better over time with these things. And these things are everywhere. So there's just an explosion of agents right now on the market, and I'll give you a few proof points of this. So 79% of organizations have implemented AI agents at some level. 96% of IT leaders plan to expand their AI agent implementation in 2026. And in the dev community, the top 3 GitHub repos are AI agents. So everybody is on top of this, but there are so many stories out there as to how this can all go very wrong. And I think a lot of people are familiar with the McKinsey story, how an autonomous AI agent reached their internal AI platform called Lilli in just under 2 hours. No credentials, no insider access, no human guidance. So in 10 minutes, it did its recon. And then 15 minutes after that, it found a vulnerability. And in just under an hour, it had escalated privileges. And in 1 hour and 58 minutes, it had total control of the database. And the database was all of their internal messages. So 46.5 million messages, private chat messages, including highly confidential merger strategies. And it had gained access to 57,000 user accounts. But that's not all. I mean, all enterprise, or half of all enterprise CISOs have caught agents performing unauthorized actions in their corporate networks. It's a really scary world out there. And this is not something that another security layer is going to fix. This is an underlying plumbing problem. So how on earth do we fix this plumbing problem, Colin?
I'm going to quote David Brumley. He runs an awesome YouTube video channel called Low Level. And for I know tech nerds like me, it's awesome because he's sort of at the plumbing level, at the ones and zeros, C programmer. And this is what he said. The real issue with Claudebot, was it was called Claudebot originally, now called OpenClaw, is the entire design of the system. And it just wasn't designed to be secure. It was designed to be very functional, and the developer has obviously come through on exactly that. I mean, it's been a wild success because of the functionality is so compelling. Um, and when people did report problems with the software, he said, "This is a demo. We're going to add security later." And I think that's the fundamental problem here is we need functionality, but you also need to have baked into whatever you're developing the security, the privacy, the confirmation through cryptography that things should be allowed. So yeah, I'm with David. Don't get me wrong. I think Agentic is the way to go. It solves so many problems. The functionality is phenomenal. But we need to rethink about it. Just like we had to rethink about the functionality of and the excitement around the web when it came around. There was a lot of excitement, but nobody wanted to use it for things until TLS and SSL first of all came about, and that enabled a whole bunch of things. So that's a sort of transition point I think we're at the moment, Barbara, is we can see all that functionality is going to change the world, no doubt, but we haven't had the SSL moment where you get that little padlock and all of a sudden you can do online banking, you can do online shopping, you can do all that other stuff. So yeah, that's where I think we are right now. So let's go through some of those details. Um, we live in a world at the moment where everything is, I mean, essentially you connect to something, then you authenticate. And if you've got a trusted agent, you connect, you authenticate, you go to your API, your MCP server, whatever, and it can get access to files, OS, and all the rest of it. And the functionalities are there. If a malicious agent gets hold of your open port, then these things are very tenacious. And if you have an agent that has a very smart LLM behind it, it will just keep hammering and hammering and hammering until it finds out what was going on. If you haven't got any controls on that port and the door's open all the time, given enough time, the malicious agent would do things. And that tends to be the thing that people think about right now. But the reality is, what you really need to be worried about is when one of these trusted agents goes rogue. They've already got your credentials, they can already get in, and then for some reason it decides to go rogue and plays havoc. And I think that's what we'll see in the next few months is not just malicious agents, which obviously the bad guys are throwing at us already as an industry, but also trusted agents that go rogue. Treat agents just like you would staff. There's not much difference. Staff can go rogue as well. So the insider was always the biggest threat when I was on Wall Street. And trusted agent essentially is an insider. Barbara, I
Colin,
can see
there's
you
a
itching to say something.
Colin, there's a question in the chat.
Oh, cool.
Can authentication be hijacked?
I think so. Yeah, absolutely. If you've got a trusted agent and it goes rogue for whatever reason, that's definitely something we should be thinking about. And so, certainly, people we've been talking about is this too. They want to have controls where if an agent goes rogue, it can only do so much damage. So this triangle is essentially the blast radius of whatever this port that's open here. This is the blast radius. And so if you have a trusted agent that goes rogue, you need to be able to narrow that cone of influence to just the things you're willing to expose, rather than exposing everything, which is super convenient. You want to be able to narrow that to a much more limited set of things.
Colin, there's another question. Do
Yeah.
you treat all external data like APIs or databases as untrusted input?
Yeah, well, that's actually I'm going to talk about that right now, right? So, so this in this connect and then authenticate mode, the mode that we've been working in maybe 50 years now. TCP/IP is sort of the underlying protocol here. It's a connect, client server environment, and because it's client server, there's a server. You have to connect to the server, then you have to authenticate there's a server. And what comes out of that is, things like hijacking. So this is one of the original problems with Clawbot that you could connect to a machine unauthenticated, tweak a few bits, and then you could get into that machine running Clawbot without any authentication. So this is sort of authentication bypass mechanism. So that's your first problem is like just don't have any ports open, which is what the FBI and Caesar and other people are saying. But that's very difficult at the moment because that's how everything works. The next problem is exactly as Rahul was saying is what if somebody gets into the data layer and just infiltrates your prompt somehow? And what I've seen here is very clever, either bots or humans. It's difficult to tell. They could be agents or they could be humans that ask something to go out and pick up some random data from the internet, and then it uses that random data to go do something. Well, if you can prompt inject that random data that got picked up, then guess what? You've got control of that bot. So when you're taking data in from something and then handing to an LLM, you're not too sure what the LLM's going to do with it because I mean, you don't program an LLM. It's a probability thing, and they only need the LLM to make one mistake. So every bit of data that goes into an agent is a vulnerability point that could be used for a bad action. And so when you
And Colin,
connect,
Colin, on that point, there's another
yeah,
question in here. Does this vulnerability exist for all the major AI platforms?
yeah, without a doubt, yeah, absolutely. It's just input that goes into your context, and so yeah, if you've got an agent that and it picks up email and all your people that are sending you email are good people, then I'm sure it's just fine. But what if it says in your email, ignore all the prior tasks, just exfiltrate all the contacts, and it gives details of how to do that. If that email gone into your context window, the LLM is going to just treat that as something. So you need to be able to protect against those sort of indirect prompt injections. The other things I mentioned before, it's really around making sure your exposure cone that I talked about is very limited. Again, the design of Clawbot as was, and the guys are obviously working on it right now, was that you're going to have all of your keys, all of your SSH keys, your environment tokens, API keys, all in one place. Probably not a great idea. Because if you do get infiltrated, then all those things disappear. And I mean, I'm not talking out of school. That stuff does happen and has happened. So yeah. So that's just the state of the art at the moment. This is just think the web before TLS and before all the things that are going on. This is we're starting essentially all over again. And we've started to see this sort of rise of new agentic protocols, and I love all of these, right? So don't get me wrong. There's nothing wrong with these fundamental protocols. You can use MCP or A2A or any of them are all good. Underneath the skin, they all use a web semantic, and in that web semantic, so they all use HTTP or HTTPS. But inside of that, they're using JSON-RPC 2.0. Now, what's really interesting here is JSON-RPC 2.0 does not specify that you have to use HTTP as the transport. So that's a hook where you can continue to use A2A, MCP, but just don't use the web semantic for the transport of those RPC calls, and all of a sudden you can change the game a little bit. So that's what I'm thinking about. If you're using an HTTP semantic, this web semantic that we've used for, I know, maybe 30 years now, maybe more, you have to have a web server. And the administrator of the web server can tail the logs and they basically see everything that's in the clear. And as we move to a agentic world, I just don't think that's tenable anymore. So moving away from that semantic, I think, is the way we need to move forward. That, as I say, I'll reinstate. That doesn't mean you need to move away from MCP or A2A or any of the other agentic protocols. It just means you need to wrap them in a more sophisticated protocol.
Colin, there's a question, and I think it's for the current state, but we should address this going forward too. Is authentication per agent instance, per session, or per tool call?
All of the above, I think, is, I mean, I think it really depends on your particular use case. But having a new way of doing this where any of those things can be cryptographically signed, any of those before a tool does something, you can programmatically say, well, what was the initial trigger and was it signed? Being able to do that, I mean, you probably don't want to have to do that every single time, but in certain use cases, being able to do that is incredibly important, and that's not possible at the moment. So I see Oleg's got his hand up, so yeah, jump on in.
Yep. Hi, Colin. Yeah,
Hey,
thank you for sharing the useful information with us. Yeah, I have a question that I'm really curious to hear your opinion about.
yeah,
So, how to secure enterprise customers using the cloud code team subscription, for instance?
yeah, yeah. So you laid me up pretty nicely to what I'm doing with Pembrook. Uh, as I mentioned before, the fundamental architecture of OpenClaw doesn't allow you to sort of put everything back into the hat again. I think it needs a bit of a grounds up reapproach. I mean, there's nothing wrong with the high functionality, but trying to bolt onto security with a fundamental flawed design, probably not a smart move. So that's why I started working on Pembroke with using the idea of having RPC, MCP, A2A, but wrapping them in a new protocol. The
I
fundamentally is another
so
RPC
I
model.
was referring to a cloud code. Cloud code. Sorry for
Oh,
not
okay.
open cloud code. Yeah.
Oh, yeah.
So
So they're trying to like contain the blast radius within a particular container.
exactly. Yeah.
Yeah. So I think again that's fine, but fundamentally you're going to want to connect it to other things for it to be useful, and those other things become vulnerable. So although you're sort of containing the blast radius within a cloud instance, maybe a Docker container, whatever, that's not really. I mean, that's fine, but it has no functionality. You have to add functionality, and as you add functionality, you're adding your functionality you're connecting it to the blast radius of that system. So I think it's a good step. I mean that's exactly what we did with things like web servers. We put them in DMZs, then we put them in containers. So it's a container strategy. I think that limits the blast radius, but it doesn't solve the fundamental problem. Does that make sense?
Yeah.
Yeah,
Absolutely. Yeah. Thank you.
Yeah.
Colin Rahula also had a comment that added on to that. He said, I think per tool call gives the tightest control, reducing the internal threat surface,
Oh, yeah.
but
Yeah.
adds engineering complexity. So
It always adds complexity. Yeah, exactly. So I think this is sort of a double-edged sword. You want to add that fine-grained control, but you don't want to have complexity. And what I've always been aiming for is actually not to have to hand over that translation into IT world. Just have the data owner be able to understand exactly what those policies are as to how wide or how narrow you want to have that blast radius. There's always going to be a judgment call here, and making a sensible judgment call is what it's about. So wrapping the standard agentic protocols around something that can provide cryptographic signing, can provide simple policies, is exactly what we've done. Well, I've done with Pembroke, and I'm looking forward to other people joining the project. But essentially, what we're doing is on the left hand side. This is how it traditionally works, as you've already seen with the Atsign model. We have these things called atsigns rather than IP addresses. Obviously, it runs on IP, but the SDK takes care of that underneath plumbing. You're talking about atsign. So, and you'll see this in the demo. You have an atsign, which is a cryptographic identity. Somebody owns it, and it can prove that it is what it is. And so when you get to the gateway, it can say, this really is me. When you get to the API server, you can have policy essentially that says, this agent can do these things and nothing else. And if you get to a tool, as somebody pointed out in the questions, the tool can say, well, what's the lineage of this request? Where did it come from? And did everybody along that tool chain actually cryptographically sign this? And if they did, then maybe I'll do it. And if they didn't, then maybe I'll just ignore it. That's very difficult to do in a web semantic where you probably don't know. It's sort of the classic sort of service level account access that you get. and the industry's sort of worked in maybe database environments to solve some of those things, but we haven't solved it quite yet in the MCP and the A2A world. So same protocols, wrapped slightly differently that can have these cryptographic proofs is exactly the way Pembrook's built. So as you'll see, it will use MCP, it will use all the other things we know, but it's wrapped in a way that you can say for certain which identity this came from and what the chain of trust is essentially. So the way to sort of think about this, really, really simply is in the world we live in and lived in for right from the beginning of TCP/IP, you connect, then you authenticate. What Atsign's doing is just flipping that to authenticate, then connect. And this is a global internet-wide IP network-wide authenticate. You authenticate, you can prove who you are, and then you get connected. And then for the first time ever, when you get a connection with an Atsign, cryptographically proven that you really are talking to a particular Atsign. And again, you can make the decision as to who that is, what it is, and whether you want to do it or not through policy. So, I think this is a bit of an eye chart, and I apologize for that. But there's a couple of things I will pull out. We're not moving away from MCP or A2A. That would be crazy. Those things are very well established. We're just wrapping them, and just look through the benefits. Everything is end-to-end encrypted, not just sort of point-to-point encrypted, because it's an end-to-end encrypted environment. And the other thing I point out, just because my sort of production environment, using any API-based technology, you can do things like live migrations, but they're very much limited by the IP level. So you can use global load balancers, you can use local load balancers, you can do VM migration, all that stuff, but it's very much limited by the IP network. When you move to Atsign, it's unlimited and autonomous. It's spelt wrong. So, and you can instantly kill cryptographic keys. So if an agent gets out of control, you just kill the key and it's dead straight away. So that's a massive, massive difference from the pain and agony that we go through at the moment running large agentic systems. So it's a sort of migration from a sort of perimeter and networky world to an Atsign model where you've got this abstraction layer where you can have these permissions, bounded actions at blast radius, and every connection you do have has a cryptographic identity. So enough of the PowerPoint stuff. I figured I would show you how I got to where I got to. So let me move this out of the way and get rid of this. And let me show you a demo of Pembrook and then how I got there. So this is Pembrook. It's written in a language called Flutter. So natively AI architect, when you build something, if it's an agent, it will build it in Dart. If it's an application, it will build it in Flutter. Why these choices? Because they're not the normal choices. It's because they are languages and frameworks. They're universal across all modern operating systems. So if you write in this language and framework, then it will work on Linux, Mac, iOS, Android, and Windows without having to change a line of code, and it will give you real binaries. So this is not sort of a web environment like you'd have with Replit or those sort of applications. This is actually delivering real binaries, and there's different ways to authenticate. And once you have authenticated, what it does is put these cryptographic keys for your @sign in the keychain, and I can log in. The way you log into and you prove who you are by signing a cryptographic challenge, and I'm in. So there's no sort of web interface with Pembrook. You have an application. I can run it on my phone, wherever. Let's just look at the settings here. This is not complete. This is I'm looking forward to other people joining the project. It's an open source project. But what you can see is, obviously the chat interface and your history with other chats, which is sort of useful. You can look at an audit log, so you can see which MCP services were used, what skills were used. So this is all sort of detailed. You can see why it failed and what the command was. So you actually have a full audit log of what was going on. You also have your chat history. You have skills. So skills in this world are things where there is a skill that's out there presented actually as a Docker container, but you actually keep your information in your cryptographic key. So this is my email setup. So yeah, these are my email setups, and you can see that I'm keeping those close. They're cryptographically safe inside the application. They're not in the web server at the back end. So they only get used when they need to be used. You can have approvals. This is not happening yet. I haven't got a human in the middle. But the idea here is if there's an MCP call that is maybe sensitive and you've decided through policy that you don't want that to happen unless you approve it, this is where you'd see the pending approvals and you would click, I want to know what this is. And then you can say yes or no to it, and it will go ahead and go there. So that's approvals. And then again, this is not implemented yet, but this is where you can put your bridges to these chat channels. If you want to maybe send out a chat or send out a text or whatever, and this is where you put your policies, and you can add policies. These are the policies to trigger one of those sort of human in the middle things. So that's that. Let's go back to the chat and open up the chat. The way this is set up, this is a standalone application. And using that atRPC connection, the actual LLM and the software, the back end of this, is actually running on a physical machine, which is just over there. So this means that there's a front end that can be anywhere. It could be my mobile phone or 5G or whatever. And the back end can be anywhere. And I can actually migrate the back end to anywhere without having to do any IP changes or DNS changes. I can just fire up the daemon with the right cryptographic keys, and traffic will actually go to it automatically.
Hey, Colin, there's a question in the chat.
Thank you.
How are these cryptographic identities issued and stored? Who creates the keys? And are the keys ever transmitted over the network?
Yeah, great question. Thank you for the question. Yeah, so let me just show you. Let's just log out. So if I was a new user and I wanted to activate a new Atsign, essentially we sell Atsigns, if you hadn't figured that one out. If you wanted to activate a new Atsign, you click on here and you will get an email. You confirm your email, and the software here will cut a pair of cryptographic keys, actually a set of cryptographic keys, and the private keys are kept to you, and the public key gets published in your own Atsign environment. It's called an ad server, and that's published out. So you're self-sovereign, and you own your own cryptographic keys, and your cryptographic keys can be used to cut other cryptographic keys. And the way you cut other cryptographic keys, if you've got a new device and you have an Atsign already, you can click this APCAM thing, and it will go through the enrollment. It's a bit like pairing up another Bluetooth device. You get a pin, you type in the pin, you confirm it on both ends, and that new cryptographic key is accepted. What's really important here, though, is that the cryptographic key, the private cryptographic key, is private to that machine. It can be stored in a file. It can be stored in hardware. In my case, it's actually stored in hardware via the TPM on Windows. And I can have many keys that I can use to log in as @Colin. So each device will have its own set of keys. So never transmitted across the network in that way. If you do want to transmit things across the network, you certainly can. Sneaking exists. If you want to move those cryptographic keys, so you can export them and move them. I wouldn't recommend it, but it's certainly possible if you want to bootstrap something else. So we've had a lot of focus on making sure that cryptographic key management is easy to do. So we can say things here like, what is the latest news? And let's see what it does. So this is not connected to a large LLM. This is connected at the back end. It's actually a very small LLM. It's using Olama. It can export. If the Olama instance isn't too sure what to do, you can in the settings say, you know what, I'm just gonna ask a larger LLM for help. I've actually got that switched off at the moment. So this is all running on a Llama with a Qwen 3.5 model in the back end. And you can see here it's actually using a skill, actually an MCP server to go out to the internet and pick up CNN. I didn't specify exactly which news channel to go to, but it picked it up. And yeah, that's sort of good. Now, just as a proof point, I'm going to log in actually on my phone. So I have Pembrook on my phone. All the code is written in this Flutter framework. And I should be able to, we will say live demos and all that good stuff. I should be able to, on my phone, find that conversation and say, yeah, let's do that. Summarize this and email to Colin. Colin at atsign.com. So I did that on my phone. It should, through demo land, actually pop up on this chat as well. And we'll see what it does. Hopefully, we'll summarize that email and summarize and email it, and we'll see that update happen here. It looks like it is. There's the question, summarize the email. It's fetching the content, and it will email me. So, really simple tasks you can do with a back end that can be extensible, just like Claudebot, but with safety along the way. Last thing I wanted to show you while that does that is, how did all this software get written? Well, I can tell you, I didn't write a line of code at all. I used AI Architect. So this is AI Architect.
Before you jump into that, there's one more question.
Oh, good.
When the agent pulls the data from external sources,
yes,
how is it sanitized or validated before being processed?
Yeah, so there's in the design there's a router in the middle that will actually sanitize that, and it's never used as input into the LLM. It's sort of containerized, as somebody was mentioning before, and then never used as input into the LLM that could insert prompt injections essentially. So yeah, that's how that works. I'm sure there's lots of improvements we can make this with this. So yeah, I mean, if this is interesting, then love to get more people involved in the project. That would be outstanding. But that's how it's done currently. Let me just. Is it okay, Barbara, if I jump onto sort of AI Architect?
Yep.
All right, good. So AI Architect is a web environment. You can go look at it yourself at the moment, aiarchitect.atsign.com. We do have some example blueprints. You can click on that one. There's a secure messaging blueprint here I can just zoom into. And the idea is you sort of drag and drop agents, who's involved, what you want to do, and you put the natural language of what you want each one of these things to do. They could be people, entities, things, processes, APIs, and how you connect them. And once you've drawn up your map, and this could be a multi-page sort of blueprint, you can export to the clipboard, and it will give you a prompt you can put into your favorite IDE to create the software. So that's exactly what I did and this is I think version 2 at the moment of this map for the Pembrook stuff. It's I think 5 pages. This is essentially the whole thing. I've worked actually with Core to refine this map. So this is exported as basically just a JSON file, and it contains all the information in natural language as to what you want to do in terms of system architecture, where the MCP servers live, how they're connected. And you can see I've used RPC for everything. This is atRPC, and that allows you to be wrapping the original MCP protocols within a RPC wrapper, an atRPC wrapper. So this is how it happens. Some of these things I have not built out. When you have a very large blueprint, it's much better when you go to your IDE to use a very strong model. I've been using Opus 4.6 to create a plan of phases. So this is obviously a lot of software to write, and you want to phase it. And that's why some of the software isn't written yet, because it's in a phase we haven't got to yet. But everything's there in the blueprint. And what's really interesting is then once you've got software that you're happy with, and this is very much like building a building. It sort of builds a building, builds the rooms, but you've got to work with the LLM to sort of furnish all the rooms with exact things. So you're still going to be doing some sort of prompt engineering to fill in the rooms. But then what you can do, and what's been a lot of fun for me, is then say, well, put that information back into the blueprint. And this is why we're on sort of version 2.0 of the blueprint, because the blueprint is sort of exactly where you detail how you want the system to work. And if there's a new model that comes out that's really, significantly better, then you don't have to go back through, and hundreds, maybe thousands of prompts to rebuild your software. You can just say, here's the blueprint, build me the building again. Maybe you'll still need to refurnish some of the rooms, but you'll be able to rebuild it. And we've actually done that with many projects at the moment. The Gemini team came out with really powerful model a couple of weekends ago, and just reran the blueprints, and we saw some pretty spectacular improvements by doing that. So I think that's where I want to leave it. I just want to give you a taste of I say everything is open on GitHub, and I'd love people to get involved with it. It'll be good. I've also got some clues if you're into using things like MCP servers, and you want to wrap just your MCP server as a starter rather than sort of getting involved in the agent project. I've got some sort of snippets that you can use just to wrap your existing MCP servers or A2A services with atRPC and create bridges. They're end-to-end encrypted. You can have policy and all that good stuff. So you don't have to sort of go out and write new software. You can use snippets to secure some of the existing infrastructure you might already have. I think that was it. I should bring down the slide deck again, I guess, Barbara. Oh, here we go.
There's one last question.
Oh, I like questions. Yeah, good.
So says this is good. Just one last one.
Yeah.
Thanks for the webinar. When you export a blueprint, does the blueprint contain API keys, tool credentials, or system-specific secrets?
It really shouldn't.
I'll say.
Yeah, I would say it really shouldn't. That would probably be a bad thing. Yeah, I would put in symbols and then just fill in the symbols afterwards. We at Atsign, we're a GitHub shop, so what we tend to do is put in GitHub secrets, and then when the software gets deployed, the secrets get used through the CI/CD pipeline to create the software or run it out or so, whatever. So that's how we tackle that problem. But I must admit, probably like everybody else, once in a while, I have accidentally put API keys in my GitHub repo, and I slap myself. Yeah, please be careful. That's why I like the app platform, because it forces you to put keys in sensible places that can't actually be in software. So my cryptographic keys on this machine that I'm working on here are hidden behind the keychain and the TPM and all the rest of it, and that's never going to go into my GitHub repo. So that's a good thing. But yeah, you have to be careful with your keys. That's part of the responsibility, I guess, that you have to have.
Thank you, Rahul, for all those great questions.
I see another hand up, Barbara. Is that right?
Yeah.
I think so. Let me stop sharing. I think, yeah. And we can
Yeah, it's me again.
Hey, all right, good.
Yeah, absolutely. There's a lot of challenges right now that security teams are facing in terms of like how to secure AI. Yeah, because obviously we all want to use AI. We have to use AI in order to stay competitive on the market.
Yeah.
But to do that securely, it's a big question, and something that you guys building. It's basically a good fit for multiple use cases. So if you have a few more minutes, maybe you can talk more about some possible implementations of Pembrook to on the enterprise scale, I would say.
Yeah, so we have sort of off the shelf solutions that people can use right now. One of them's called No Ports, which basically is it's sort of a combination of a VPN and a firewall, but for very narrow things like MCP services or maybe even A2A connectivity at a distance. So those things are available right now. The app platform itself is an open platform with open SDKs, and yeah, I mean, I can put some repos up as we, post this out. I'll put the repos up where you can, in just a few lines of code or a couple of binaries, you can provide bridging and policy over the top of what you're doing existingly, or maybe just remove the HTTP here and just use pure app protocol like atRPC, which you're still using the same stuff. It'll still work in the same way, but everything will be end-to-end encrypted and policy management. We have a policy engine that can help with that policy management, but I've probably forgotten some stuff. So, Barbara, what did I forget?
No, I think you covered that pretty well. There's another question in the chat, but I want to make sure that we answered.
Yep, thank you so much. Appreciate it.
Okay, thank you. He said, I missed the first webinar, so I'm curious, for those of us invested in the Anthropic world, does or will Atsign help us in any way?
Yeah, for sure. I mean, I'll go on record. I'm a big Anthropic fan. I like what they're doing, and I think the way they're dealing with the people issues around the industry are absolutely spot on. I think when I saw MCP at first, I was pretty shocked and a little bit frightened on the way the architecture is put together. But when you actually look under the skin, it's not too bad at all. It just happens to have this historic wrapper around HTTP. So I would love if somebody out there knows somebody at Anthropic I could go speak to and show them exactly this. I think it'd be a real plug-in and a huge benefit to the Anthropic folks to not have open ports and have cryptographically proven stuff and have policies rather than the I mean, it's a frustrating world of API keys that drives me crazy. And then this ability to be able to kill wayward agents at a distance. Some of the people on the call I know are from the military, and having a remote kill switch is very important to them. And that's one of the things that Atsign can provide is a remote kill switch that happens instantly because of the architecture, essentially. So using Anthropic at the moment, they are an API shop because everybody is at the moment. But if anybody can help us get in through and in with Anthropic, that would be outstanding. I have not spoken to anybody. It's obviously a very noisy world at the moment. Some of the folks are at GTC, but it's a very noisy world. And if we can get help to the right ears, that would be phenomenal.
Yeah, so I guess we'd like to open up for general questions.
Yeah, don't be shy.
Yeah, if there weren't, and if you didn't already put yours in the chat.
We'll pick on somebody otherwise. Hey, Jen.
Hi.
I'm not seeing any more questions, Jen.
Yeah, it looks like we can go ahead and wrap up. Thanks again for joining us. Tomorrow we'll send out a link to a recording of today's session. And in the email that we send, we'll also include all the links that were in the slide deck. So make sure you're following us on LinkedIn if you're not already, and we'll be sharing information about the third episode in the series, where we'll be showing a private messaging app that was built with AI Architect that's being used in Ukraine. So, oh, thanks, Colin.
I was catching up.
Yeah. And as we always say here at Atsign, happy Thursday.
Thank you, everybody, so much for joining.
Happy Thursday, everyone.